Welcome back. Let's learn about while loops. While loops repeat a block of work as long as a condition stays true. Think of it like asking a question before every lap on a running track. If the answer is yes, you run another lap. If the answer turns into no, you step off the track and finish. In practice, this means we must make sure something inside the loop moves us towards stopping, otherwise it would run forever. Over this demo, I will show safe patterns, common mistakes, and practical uses. Here is the most common pattern you will write. We set a starting value, then loop while a condition remains true. Before each loop, Python checks the condition. Inside the loop, we do the work and update our variable so the condition will eventually become false. This gives us predictable, controlled repetition. Watch how the value steps down to 0, then the final message prints after the loop ends. Two handy keywords control loop flow. Break means stop the loop right now and continue after it. Continue means skip the rest of this lap and jump to the next check. Use break when you have found what you need early. Use continue when you want to ignore a case and keep going. This example skips blank or commented lines, and it stops when the word quit appears, even if there are lines left. Python has a useful pattern called while else. The else block runs only if the loop finishes naturally without a break. Here we allow 3 attempts at a password. If the user enters the secret correctly, we welcome them and break, so the else block does not run. If they use all attempts without success, the loop condition ends, and the else block handles the lockout message. A classic mistake is forgetting to change the variables that control the condition. That creates an infinite loop. In your terminal, you can stop it with Ctrl and C, but it is better to prevent it. Add updates inside the loop, and for long-running tasks, add a safety counter or a timed exit. This example shows one loop that never updates, and then a safe version that always moves toward the stop. Challenge time. Your challenge is to build a guessing game. Pick a secret number between 1 and 10. Keep looping until the player guesses correctly. Count how many guesses it took. If the guess is too low, say higher. If the guess is too high, say lower. Start from this scaffold. Fill in the to-do items, then test your loop. Aim for clear messages and a clean exit when the player wins. Pause the video and give it a try. Post your answer below, and please don't forget to subscribe. Here is one clear solution. We loop forever and ask for a guess each lap. First, we validate that the input is digits to avoid crashes. After conversion, we bump the attempts counter. If the guess is lower than the secret, we encourage higher and start the next lap with continue. If the guess is higher, we suggest lower and continue. When the guess equals the secret, we celebrate, include the attempt count, break out of the loop, and finish neatly. How did you go with the challenge? Before we wrap up, here is a reusable pattern that keeps your program friendly. We loop until the user gives a valid positive integer. Try to convert, catch errors, and keep prompting with helpful messages rather than crashing. When a valid value arrives, we break and carry on. This structure makes the rest of your code simpler and safer because it receives clean inputs every time. Great work! Today you learned the while loop mindset. Ask a question before each lap, do your work, and move toward stopping. You used break to exit early and continue to skip a lap. You saw the while else pattern for clean success and failure messages. You also practiced a friendly input loop and built a complete guessing game. In the next lesson, we will compare while loops with for loops and the range function for count-based repetition. Don't forget to hit that subscribe button.